Now today we shall discuss about similar triangles. This is a very important topic of class 10 geometry, and I wish if you sit in the class with your notebook and pen, that will be very nice. Now let me just begin it in 2 minutes. I am waiting for few more people to join. Let's wait for few more minutes. Now see, meanwhile let me just give you an idea what we mean by similar triangles. So before going to the triangle, let me talk about similar figures. Similar figures. Now in your earlier classes you have also come across congruent triangles. So that those are congruent figures. Fine. That is congruent figures. Congruent figures. So we need to understand very clearly what we mean by similar figures and congruent figures. If this basics will be clear, then it will be easy to understand. Now, congruent figures or congruent triangles, as you have studied. The word congruent means equal in all respects. What I mean by all respects, whether you talk of their shape, size, angles, etc., all are equal. If two figures are congruent, then they have same shape, same size, same angles, and anything else you can think of those two figures, they are equal. Fine. In case of similar figures, we have look alike figures. Look alike figures. That is, those which are looking alike. Their size may not be same, like this triangle and this triangle. Their shapes are same, but second triangle is bigger than the first one, right? So their sizes are different, but they are looking alike. They are looking alike each other. So these are similar figures. Whereas in congruent triangles, we mean if we say that two triangles are congruent, this and suppose this triangle, I say they are congruent, that means they are, I name this triangle as A, B, C, this is D, E, F. Then what I mean, this side AB will be equal to corresponding side DE. BC is supposed to be equal to EF, and AC is supposed to be equal to DF. Angle B is equal to this. Angle A is equal to angle D, and angle C is equal to angle F. That means anything we can think of about these two triangles, they will be equal. That situation is called congruency. So in your class 8, you have learned about congruency, and in detail you have gone through, and also the criteria of congruency when two triangles can be congruent or whatever it is. Now today we are going to discuss about similarity. Similar triangles. This is a very important topic of class 10. Once again, I am repeating. Sit with your notebook and pen so that you can note down the important things which I stress on. Fine. Now, as I said, similar figures, or to be more specific, similar triangles, they look alike. That means this side, suppose I call this as P, Q, R. This is a triangle. This is M, N, O. The sides PQ may not be equal to MN. Similarly, none of the sides may be equal. Ultimately, their shapes are similar, looks alike. Fine. So this is the meaning of similarity. So when the two triangles, let us be more specific and let us slowly approach to the topic. When two figures are, or two triangles are similar, their sides are proportionate. This is the effect of similarity. Not only for triangle. Suppose I have, say, let me just consider a quadrilateral. This is a quadrilateral. Let me name it as A, B, C, and D. And another quadrilateral, if I take, sorry, I should take a similar one like this and like this. And if this side is suppose 2.1 units, this is 1.5, this is 2.5, this is 2.4, and in this triangle, this is 4.2, this is 3, this is 5 units, and this is 4.8 units. Let me name this also as P, Q, R, S. Fine. Also, their angles. This angle is, suppose it's more than, let me call it as 105 degree. Then this angle is also 105 degree. This is 85. Suppose I'm just giving a value to this approximately as the angles are appearing to me, right? These are not the exact value. And this is suppose 70 degree, then this is also 70 degree. Now, as the sum should be 360, this angle has to be 100 degree, and this is again 100 degree. Now, these two figures are similar. Now, similarity is symbolized by this symbol. I can say A, B, C, D quadrilateral is similar to P, Q, R, S. Fine. In case of congruency, we used to use A, B, C triangle is congruent.
Incoming voice call from +91.
Congruent to triangle D, E, F, right? Now note this. This is congruency and this is similarity. Fine. So hope the idea of similar figures is clear. Now also in these two figures, notice one thing. These both are similar figures. First pointed, they are similar. Now we see that corresponding angles are equal, right? So second outcome is in similar figures, corresponding angles are equal. Or I can say similar figures are equiangular figures. They are equiangular shapes or figures. This is the second outcome we are getting out of it, right? And thirdly, and very important, is that if you observe, side AB here is of length 1.5. Corresponding side PQ in this figure is of 3 units. So if I take the ratio, what is the ratio? 1.5 on 3. This ratio is 1:2. Now when I compare BC, that is BC, and corresponding is QR. BC is 2.5 and QR is 5. When we simplify, again we get 1/2. Similarly, if I take the ratio of CD and RS, CD is 2.4, RS is 4.8. On simplifying it, 1/2, and the last one, DA, is 2.1 and SP is 4.2, is again 1/2. So very important point is that the sides, rather corresponding sides are proportionate. What we mean by proportionate? That means they bear a constant ratio. They bear a constant ratio. Means साइड्स का आपस में रेशियो सेम होता है. ये रेशियो है 1:2, 1:2, 1:3 और 4 साइड का भी 1:2 है. तो नाउ वी हैव 3 very important conclusions for similar figures. I am talking very much general, not about triangle. Any similar figure, it can be quadrilateral, it can be triangle, it can be pentagon or any polygon. The only mandatory part is they should look alike. Once they look alike, we can think that they may be similar. Second thing, what we should check here is they should be equiangular. And once they are equiangular, the sides are to be proportionate. तो ये 3 points, ये 3 points जो हैं, ये आपको अच्छे से समझ जाने चाहिए. Hope I am very clear. Okay. Now let us specifically start talking about triangles. The very first and the important theorem which you have in class 10 is basic proportionality theorem. In short, we call it BPT. Fine. It was first given by Thales, and sometimes it is also referred as Thales theorem. Right? तो ये चीजें आपको पता होनी चाहिए और ये बहुत इंपॉर्टेंट है. For sure 5 mark question is expected on this theorem. Direct question can be expected that state and prove BPT, or sometimes the statement is given and you are to prove BPT. Clear? Let us see what is the statement. First of all, statement. Write the statement of the theorem in your notebooks along with me. Understand each and every word, because here each and every word is very important. If first I am just reading it out, then I'll write it out. right? You can copy down what I write. First, try to understand it. A line drawn parallel to one side of a triangle. That means there is a triangle. Fine. There is a triangle. So let us first have a triangle ABC. If a line is drawn parallel to one side of a triangle, any one side, if I draw a line parallel to one side of a triangle, say I have drawn this line DE, which is parallel to BC, right? Intersecting the two sides. Remember that. What type of line we have to draw? We have to draw a line which is intersecting the two sides into distinct points. It must intersect into distinct points. क्योंकि लाइन यहां से भी जा सकती थी, right? This line is not valid because here the point of intersections are coinciding. Clear? लाइन यहां से भी जा सकती है इसके पैरेलल, but that is not intersecting the sides of the triangle. So clearly the statement goes, if a line drawn parallel to one side of a triangle intersecting other sides in two distinct points, divides the two sides in same ratio. This is the statement of BPT or basic proportionality theorem. So what it is, once again I am reading it out. If a line is drawn parallel to one side of a triangle, like DE is parallel to BC, right? Intersecting the other two sides in two distinct points, divides the two sides in same ratio. That means the ratio of these two parts of this side and this side is same. Fine. So this is the statement, and what we have to prove? To prove it divides in same ratio. That means AD upon DB is same as AE upon EC. So this is what we have to prove. Hope till here we are clear. Once again, let us see how we will proceed for the proof. Clear? Now, before we start the proof, let us just make some constructions. क्या constructions होंगे इसमें? जैसे हम थ्योरम्स में कंस्ट्रक्शन करते हैं, उसी तरह यहाँ भी कुछ कंस्ट्रक्शन करना पड़ेगा. So what is the construction? From E, draw a perpendicular to this side. From E, draw a perpendicular to AB. And from D, draw a perpendicular on AE. Fine. After drawing these two perpendiculars, join B, E and D, C. Clear? So what construction we did? Draw. Let me name E, F and G. Draw E, F perpendicular to AB and DG perpendicular to AC and join BE and CD. This is what is our construction. Now let's move with proof part of it. Now in proof, first of all, what I'll do, I'll just in brief, I will let you know this triangle and this triangle. We will just consider area of triangle ADE on area of triangle EDB. Now as we know, area of a triangle is half base into height, that is half. Let me take AD as base, then EF is the height. Half of AD is the base and EF is height. Similarly, for this triangle, it is half, and this triangle EDB, the base is DB. Remember, here there is a confusion. Base is DB, and height is same EF. Fine. Let us just simplify it. Half and half will cancel. EF and EF will cancel, and we are with AD upon DB. Let me call it as 1. And again consider same triangle and this triangle now. Again, area of triangle ADE upon area of triangle EDC this time. EDC. Fine. The same triangle. First we took this triangle, we compared. Now we are taking this triangle for comparing. Fine. This is equal to again half base. Now base I'll take AE from this side. AE. And altitude is DG. Upon half. In this case, base is EC, and altitude is DG. Simplifying it, cancelling half and DG, we get AE upon EC, and let us call it second relation. Fine. Now see, this is very important. So far it was very easy. What was the first step? We took this triangle ADE and compared it with this triangle, and in the second step we compared it with this triangle. Fine. And we got two relations here, 1 and 2. Now see, compare the relations 1 and 2. Numerator is same in both the cases. Fine. Area triangle ADE in 1 is same as area triangle ADE in 2, and area triangle EDB of relation 1 is equal to area triangle EDC in 2. Sorry, this is 1. Fine. This is 2. Now see, this point is important here. This is EDB. EDB. Note it clearly. Triangle EDB. ये वाला triangle and ये वाला triangle, they are equal in area. Why? Triangles on same base, in दोनों triangle का base we can consider DE, same base, that is DE, and between same parallel lines. Here what are the parallel lines? DE parallel to BC, BC parallel to DE are equal in area. ये बहुत important theorem है which you have learned in class 9. Fine. This is very important step. You have to note it. Clear? Now the things are very simple. So we can say that left hand side of 1 is equal to left hand side of second relation. Therefore, right hand side of first relation should also be equal to right hand side of second relation. That is AD by DB should be equal to AE by EC. And this is what we had to prove. यही हमें prove करना था. Fine. Hence, proved. Now this theorem is very, very important. Once again, I am telling, and number of times it has come in a long question in board exam. Fine. Let me just see some more application of these things. Now see here, I would like to mention, now what was the theorem? Theorem was, if a line is drawn parallel to one side of a triangle intersecting the other two sides in two distinct points, then it divides the two sides in same ratio. Its converse is also true. Converse of BPT is also true. So we can apply the converse. So what the converse will say? If a line intersects the two sides of a triangle in the same ratio, if a line intersects two sides of any triangle in same ratio, the line is parallel to third side of the triangle. Fine. We will not go into the proof of this, but we will remember this, and this can be applied in solving questions. Okay, Let me just take a simple question quickly. The so it's a let's take one question. What question says if a line intersects sides AB and AC of a triangle? There's a question from your book. If a line intersects sides AB and AC, AB and AC of a triangle ABC at D and E respectively, and is parallel to BC, then prove that AD upon AB is equal to AE upon AC. So this is a question. Is a question from your book. So there is a triangle here. Let's see how we go about it. This is a triangle A, B, C. A line intersects sides AB and AC. Means this is the lines intersecting the sides AB and AC of triangle ABC at D and E. This point is D and this point is E respectively, and parallel to BC. This line is also parallel to BC. The solution, just now we did a theorem which says that if a line drawn parallel to one side intersecting the other two sides in distinct points divides the two sides in same ratio, that means according to BPT, that is basic proportionality theorem, we have AD upon DB is equal to AE upon EC. Fine. But what we have to prove? We have to prove AD upon AB. यहाँ पर है DB. AE upon AC. यहाँ पर है EC. Fine. So now see how we will go it. In the first step, since this is a ratio, I can take the reciprocal. The ratio remains unchanged. That is, I can write it dB upon AD is same as EC upon AE. Fine. In ratio proportion, this step is called invertendo. That means the ratio can be inverted. Okay? Don't go or don't worry about remembering this. I just telling, if you can remember, it is this property is called invertendo. Fine. In the next step, excuse me, in the next step, let me add 1 on both sides. Now this is also a property. Adding 1 on both sides of a proportion, this is a proportional statement, is called componendo. So what property I have used here? Invertendo and componendo. Those who have done the chapter of ratio proportion in class 7 may be knowing this. Okay, But even if you don't know the names of these properties, nothing to worry. Now what we get? We get AD plus DB by AD. Fine. And this side we get AE plus EC on AE. Fine. Now you can see clearly AD plus DB is nothing but AB. It is AB by AD, and this is AC by AE. Fine. Now almost we have arrived at the conclusion, but we need one step of invertendo. Let us invert. This implies that AD by AB is going to be same as AE by AC. Fine. This is our result. Hence, proved. See, in geometry, the demand is systematic approach in solving. Usually students lose lot of marks because they don't follow the steps in continuation. There should not be break. There should be reasons at every step. Fine. Simply arriving to the result will not serve your purpose. Clear? Let me see another problem quickly. I have a triangle. Here, say A, B, C, and this line is parallel to BC, say D, E, and this is 1.5, this is 3, this length is 1 unit. What is this length? You have to find x. Now, by the theorem, we know it that if this line is parallel to this, then these two pieces, these two parts of the sides are going to be in the same ratio. Okay. So what is it? 1.5 on 3 is same as 1 on x, which implies that x is going to be 2 units. इस तरह के क्वेश्चन भी आपकी एक्सरसाइज में है. एक और ऐसा ही क्वेश्चन थोड़ा अच्छा लग रहा है. Let me just quickly solve it. This line is parallel. We have to find this time this side. This is 1.8. This is 5.4. This is 7.2. We have to find x. So here again, x on 7.2 is equal to 1.8 upon 5.4. Simplifying, x equals to 1.8 on 5.4 times 7.2. This is thrice and 3 to the 6 and 1 4, 2.4. So in this case, x is 2.4. Fine. And we will try one more question and then we'll move to the next concept in this concern. Fine. What is the question is, a trapezium is given. What is trapezium? Trapezium is a quadrilateral with a pair of opposite sides parallel and the other pair of the opposite sides is oblique, that is not parallel. So this is a trapezium AB, CD in which you have DC parallel to AB and its diagonals are intersecting at O. We have to prove that B we have to prove that AO on CO is equal to BO on DO. This is the question. Now here we know that this line DC is parallel to this line. A small construction we will do. Through O, draw a line OE parallel to AB. So automatically this is going to be parallel to DC. Fine. This will be parallel to DC automatically because this is parallel to this and these two lines are mutually parallel. Okay. Now in triangle DAB, EO is parallel to AB, implying that DE upon EA is DO upon OB. Okay. And again, call this as 1. In triangle ADC, now AE on DE is equal to AO on OC. Call it 2. Now see, if I invert it, it gives me DE upon AE is the same as OC upon AO. Clear? Now this side and this side are equal will imply that DO on OB is equal to OC on AO, right? Or revert it, AO CO is equal to BO on DO. Hence, proved. These are not very difficult once you understand. The only thing is that you must present your solution in a very, very systematic manner because every step counts for the marks. Okay. Now, there is another important part of this topic, which is criteria for similarity. Now, let us discuss important criteria for similarity. That means, like how while studying about the corresponding or congruent triangles, we had the criteria for congruency. Similarly, we are having criteria for similarities. So first criteria is A similarity. That means what it says, in two triangles, if all the angles of one are equal to corresponding angles of the other triangles are similar. That is, यदि एक ट्रायंगल के तीनों एंगल किसी दूसरे ट्रायंगल के तीनों एंगल के साथ इक्वल हों, मतलब एंगल A इक्वल टू P, B इक्वल टू Q, C इक्वल टू R, द ट्रायंगल्स आर गोइंग टू बी सिमिलर. अब इस प्रॉपर्टी में एक छोटी सी बात सोचने वाली है. यदि A P के बराबर है, एंगल A इक्वल्स टू एंगल P, and angle B is equal to angle Q, तो ऑटोमेटिकली C will be equal to R. क्लियर? तो हमें तीनों एंगल की जरूरत ही नहीं है. इस प्रॉपर्टी को हम रिड्यूस कर सकते हैं A सिमिलैरिटी. यदि किसी दो ट्रायंगल में यदि दो एंगल एक ट्रायंगल के दो एंगल दूसरे ट्रायंगल के इक्वल हों तो तीसरा ऑटोमेटिकली इक्वल होगा और ट्रायंगल्स सिमिलर होंगे. ओके, यह है पहला क्राइटेरिया. दूसरा क्राइटेरिया है, जैसे आपका कॉन्ग्रुएंसी में था, सेकंड क्राइटेरिया SAS मींस साइड एंगल साइड. कॉन्ग्रुएंसी के केस में टू साइड्स ऑफ ए ट्रायंगल आर इक्वल टू द टू साइड्स ऑफ अदर ट्रायंगल. यहां पर इक्वालिटी नहीं होती, प्रोपोर्शनलिटी होती है. इफ टू sides of one triangle are proportional, remember this word is important, proportional to corresponding sides of the other triangle, and their included angles are equal. देखिए, एंगल्स इक्वल ही होंगे, included angles are equal, then triangles are said to be similar or they are similar. This is second criteria. ये सारे क्राइटेरिया प्रूफ की इनकी आवश्यकता नहीं है, आप इन्हें याद रखेंगे. ओके. और तीसरा क्राइटेरिया है SSS. All the three sides of one triangle are proportionate. ध्यान रहे, proportionate to the corresponding sides of the other triangle. Triangles are similar. ये 3 important क्राइटेरिया हैं जो हम प्रॉब्लम सॉल्विंग के समय अप्लाई करेंगे, और ज़्यादातर थ्योरी सिमिलर ट्रायंगल्स के बारे में सिर्फ इतना ही है, और इसके बेस पर आपकी बुक में there are 3 exercises. 6.1, which is a very very basic, contains very few questions, fill in the blanks and short type of objective questions. And second exercise is a little bit important, having perhaps 8 to 10 questions, and you should try them. And the last exercise is also having 12 to 15 questions around, and they are important. So please do try each and every question. In case you find difficulty, do write me in comment. I'll take another session where exclusively we will discuss about the problems and their solution. Fine. Thank you very much for being with me. Hope you like this session. Do inform your friends also to join the session and be benefited. And stay healthy. Good luck to all of you till we meet the next time. Thank you very much once again.